Okay, so welcome to today's class where we are going to introduce this topic called kinematics. Okay, so kinematics simply means movement or motion. Okay, so in this topic, it's all about motion. Okay, so what does that mean? It means we are going to concentrate on the following three concepts. One of them is that we are going to concentrate on displacement. Okay, we're going to concentrate on displacement, and then the second one is that we are going to look at velocity. Okay, velocity and a bit of speed. And then the third thing we are going to look at the what? The acceleration. Okay, so under this topic kinematics, these three here will be the main things that we'll be talking about. Okay, so we have a whole lot of things to talk about because there are different scenarios. We have linear motion under kinematics. We also have projectile motion. Okay, so all those things we are going to talk about them. But for the introduction today, uh, we are going to know what this displacement is, what the velocity, the speed is, and how to find this acceleration. Okay, and then we are going to solve some few questions just on the concepts that we will look at. Okay, all right, so we'll start with the definition of what displacement is. Okay, so displacement is simply distance with direction. Okay, distance with direction. If you are moving, or if you've moved 5 meters to the north, okay, 5 meters to the north, this here is displacement because we are considering what? Direction. Remember when we are talking about vectors, okay, we said vectors have direction, and we gave an example of this displacement to be one of those the vectors, right? Okay, so meaning that whenever we talk about the displacement here, we would have to include the direction where the displacement or where that distance is going. So displacement is simply distance with direction. Okay, and then what about the velocity? Okay, what about the velocity? So I'll keep this class as simple as I can. So the velocity is just the change in this displacement. Okay, so the velocity is simply the change in the displacement. Okay, um, so we have velocity here, and then on the other side I'm going to write speed. So it's very important to know the difference between these two quantities. Okay, so speed is just a scalar quantity. Okay, it does not have direction. Okay, and then this velocity is just simply speed with what? Direction. So this is speed with direction if we are to keep it plain. So speed with the direction. Okay, so some people say that the velocity, the official definition now, you can say that it's just the displacement, okay, per unit time in a particular direction. Okay, so we are saying displacement per unit time in a particular direction. So this is what velocity is, particular direction. Okay, so whenever we talk about velocity, we'll be talking about a quantity that has what? Direction. So the formula on how to find this velocity is as simple as this. Okay, we are going to be saying that velocity is equals to, okay, the distance covered per unit time. So this here is the formula that we're going to be using in order to find what? The velocity. Okay, and then let's say for example the distance is maybe 18 meters. Okay, and then the time is 6 seconds. So it means your velocity there will just be simply what? 18 divided by 6, which will be 3 meters per what? Per second. So this is the formula that we are going to be using to find the definition. Of course, we are going to modify this formula. We are not just going to be using it as plain as we can see it here. No. Later on, I will talk about the equations of motion. Okay. So now let's talk about the acceleration. So the acceleration is simply defined as the change in the velocity per unit time. Okay, so we're going to say acceleration acceleration is equals to the change in time divided by the the change in velocity there. Okay, so the velocity should be on top. The change in velocity divided by the change in time. So this is the formula for velocity, and we can get the definition from this very formula. We're just saying acceleration, okay, is defined as the change in velocity per unit time, and then it is expressed in this form. So we know that this velocity, okay, from the previous example, it has the units meters per second, and then the time has the units what? Seconds, like that. So meaning this acceleration here, we have the units what? You are going to divide this meters per second with the second, so we get meters per squared second, like that. So these here will be our what? Our units for acceleration. Those will be our units for velocity, and then these will be our units for what? For time. Okay, and then from there we can talk about the 5 equations of motion that we are going to be using under this topic. Okay, so these 5 equations of motion, if you are taking a pure physics at grade 12, you did them. Okay, so these equations, they are used to find the same thing but in different ways. So they have different quantities in those formulas. Okay, so the first one is written as V is equals to U plus AT. So this U here represents initial speed or initial velocity, and then this V here, okay, will be representing what? The final velocity. So take note of that, and then we know that the A is the acceleration, and then the T is the time. So this is the first equation of motion, and then the second one, okay, it will be S. Some people just write X like this, is equals to UT plus 1 over 2 AT squared. Okay, so this U, we said, is the initial velocity. Okay, so now what is new here is the X. So the X here simply means the displacement. Okay, the displacement. So some other books, they show this X to be S. Okay, so if you see where this S there, someone puts S, it's just the same thing. Okay, so this is the second equation of motion, and then the third one, we have that this same displacement is also equals to half, and then I have initial velocity plus final velocity multiplied by time. Okay, the third one, is it fourth one? So the fourth one, we write it as final velocity squared is equals to initial velocity squared plus 2 multiplied by the acceleration multiplied by the displacement. So this is the fourth one. And then finally, we have the fifth one, okay, which is given as displacement is equals to final velocity multiplied by time minus 1 over 2 AT squared. Okay, so these are the 5 equations of motion. So how do you choose which one to use when you are given a question? Okay, it all depends on the quantities that you've been given in the question. Okay, so if in your question you have the final velocity, you have the initial, you have the acceleration, then you can use it to find time. Okay, let's say in your example you are given maybe the final velocity, the time, and the acceleration. Okay, and this one here is the most used equation, this one here. Okay, maybe you have the final time and the acceleration there, then you can use that to find the what, the displacement. Okay, so it all depends on the scenario of the question that you've been given for you to choose which equation you are going to use for that specific what question. Okay, so you can take a screenshot of these equations. They will be very important as we go into this topic of kinematics. Okay, and then from there I would like to talk about the velocity time graph. Okay, velocity time graph. Then from there we can solve some example question just on the basic concept of what, kinematics. Okay, so the velocity time graph is something like this. I'm sure you've seen it before. Okay, it's there in math for grade 12, and I know you did math, so I know you know this graph. Okay, so on this vertical axis we are going to put our velocity, and this velocity will be in meters per second. Okay, and then on this horizontal axis we are going to put the time, and this time will be what, in second. So it's very important to understand this velocity time graph. Okay, it's very important to understand it. Why is it important? Because it's going to be helping us to find maybe the distance, okay, or the acceleration or the velocity. Okay, so we can have 0 here, maybe we have 5 seconds there, then we say 10, maybe 15, and then here on the speed maybe we have 2, 4, and then 6. Okay, so the question, the way it comes in descriptive form. So you have to get that description that you've been given in the question, and then you apply it on this velocity time graph, and then that's when you can answer the questions. Okay, so if you won't have the skill of getting the description and then drawing it, okay, it will be very difficult for you to answer questions. So we have to have the skill. So for example, let's say they say a car starts from rest. Okay, so when they say a car starts from rest, they mean it's starting at this velocity, which is 0. Okay, and then maybe they say it accelerates until 5 seconds. So it means from rest, which is 0, it has accelerated until what, this 5 seconds, and then it will have a certain velocity where it will reach here. Okay, and then they can say maybe from here it travels at a constant speed for 5 seconds. So meaning from this 5 we're now going to the what, to the 10, and then after that it goes to rest in another 5 seconds. Okay, so you have to know how to interpret that information that you are given in the question. Okay, and then from this velocity time graph it will be very useful for us to find the distance. Okay, let's say the distance traveled in the first maybe 5 seconds from 0 to 5. So what are we going to be using in order to find the distance? Okay, we're just going to be using the concept of the area under the graph. So for example, if I want to find the distance that this car traveled from 0 to 5 seconds here, I just have to find the area under this graph like that. Okay, so how do we find the area under this? Okay, remember the formulas that we use to find the area of a triangle. Okay, so if we have a right angled triangle, we are saying the area is just 1 over 2 BH. Okay, so this is the formula that we are using. Okay, so we're going to adopt this formula, and then we're just going to say the displacement is equals to half. Okay, and then the base here is represented by time, so we can say time, and then the height here is represented by the velocity, so we can multiply by vt there, or you can just write half vt like this. So we're going to be using such equations here to find the distance there. So this formula that you're going to use in order to find the distance, it will depend on the shape that you have. Okay, it will depend on the shape that you have. So let's say, for example, the distance that you want to find is making a rectangle or a square. Okay, let's say it's making a rectangle like this. Okay, so how are we going to find the area of this? We know that for us to find the area of a rectangle, we just multiply b multiplied by h like that. Okay, so it means area or distance, if this is the shape that we have, it's just going to be equals to b multiplied by h. Okay, so this will be our distance. What if it's a square? We know that a square has equal sides, so it means here we are going to have a there and a there. Because it's a square, it has equal side, so it means our distance will just be what? A squared. Okay, and then what if we have this shape here? Okay, so this shape is a trapezium like that. So what if we have this shape here? Okay, so remember the formula for finding the area of a trapezium. We said half BH, and then was it half BH? Okay, I think I've forgotten that formula. Let me remember it.
The formula is
Uh-huh.
1 over 2 open bracket a plus b close bracket h.
Okay, so 1 over 2 and then a plus b, right? And then h. So this is the formula, yeah. So this formula here, we are going to be using it to find the area of what? This trapezium here. So this a here represents the distance, the shorter distance, meaning from there all the way up to here. And then this b represents the long distance from there at the start of this shape all the way up to the end. This will be our b. And then this will be our b, that will be our a. And then this height here, okay, is represented by h. So we can use this formula to find the distance. Okay, so those are the things that we are going to be using. Okay, so now let's look at some practice problems based on whatever I've explained here. Okay, whatever I've explained here, let's look at some practice problems. Okay, so the first question is this question that we are seeing here. Okay, so the question, they're saying the velocity time graph of a runner is shown in the figure below. Okay, so this is the velocity time graph. So we can see that on the y-axis here we have the velocity, on the x-axis we have the what? The time in seconds. Okay, and then we have this motion that is being described here. Okay, so we should know how to interpret this motion. Okay, so it means this car, or this run I mean, okay, is starting from rest and then is accelerating, okay, all the way to 2 seconds, because the time here is moving in 2. So this is 0, 2, 4, 6, 8, 10, 12, 14, 16. Okay, so it moves from 0 second to 2 seconds. Okay, and then it moves at a constant speed all the way up to what? 10 seconds there. And then from there it deaccelerates up to 12 seconds, and then now it moves at a constant speed all the way up to what? 16. So from this now, what are the questions that they are asking us to find? Okay, what are the questions that they are asking us to find? So the first question is that how far does the runner go in 16 seconds? Okay, so meaning starting from here all the way up to here. Okay, how far has that runner traveled? Okay, or how far has that runner uh, moved? Okay, so to find that, what are we going to do? Okay, to find that, what are we going to do? We are going to use the area under the curve. Okay, we're going to use the area under this curve here. So how are we going to do that? We can separate this curve, okay, into various shapes that we can see there. Okay, we can separate it into various shapes, and then we try to solve for the area of those shapes. Okay, so the first shape that I can see is this guy here. So this guy here in red makes a what? A triangle like that. Okay, and then the second one I can see is this big, I don't know if it to be a square or a rectangle. So this one I'm writing in blue like that. Okay, so you can say this is my shape B, this here is my shape A. And then what other shapes can I see? Okay, I can see a a trapezium there. Okay, so from here, this one I'm drawing in yellow, going like that, going like that, and then coming like that. Okay, we can see it's a shape, so we are going to name that as C. And then now going to 16, we can see we also have a what? A square there. So we are going to name this shape as D. Okay, so we have how many shapes there that we've found? We have 4 shapes. Okay, so in order to find the total displacement from 0 seconds to 16, okay, we are going to add the area of A, the area of B, plus the area of C, plus the area of what? D. So let's identify the shape A. So the shape A is a rectangle, so it is like this. Okay, so this is our shape A. So from here, the starting point up to there, okay, we can see here from here 0, we are going to 2. So it means this here is going to be 2. And then the height, when you start from here all the way up to here, is going to be what? 8. So that will be 8. So we can use the base and the height to find the area, okay, which in that shape that we found. So we are going to say the first displacement is just equals to 1 over 2, and then we multiply 2 multiplied by 8 like that. So when we multiply this, what are we going to get? So it will be 8, right? Because this is half multiplied by 2, which is 1, and then 1 multiplied by 8. So we are going to get 8 meters. Okay, so the displacement for A is just what? 8 meters. Okay, what about the shape B there? Okay, so the shape B is this guy here. So we have, let me use blue. So for B, we have this. Okay, something like a square, or I don't know if it's a rectangle. So where it is starting here, it is 2. So here it's 2, and then where it's ending here, it's 10. So we're going to put 10 here. And then height wise, okay, it's just from 0 all the way up to 8. Okay, so it means the height is 8, and then the length here is what? 10 minus 8, so it's 8. So it forms a square. So this is our B. So how do we find the area of a square? Okay, we just what? Multiply 8 multiplied by 8. So we are going to get what? 64. So we are going to get the displacement from the shape B is just 8 multiplied by 8, which will be equals to 64 meters. So guys, if you have any questions, please feel free to ask. So for the shape B, we have 64 meters. Okay, let's now find for the shape C. Okay, so let's extract the C. The shape C is coming like this. That's a bad drawing. It's coming like that, like that, like that, and then we are joining this like that. Okay, so we said this is a what? A trapezium. So we are going to say this here will be our short distance A, this here will be our long distance B, and then this here will be our what? Our height. So where is this starting? This shape that I've drawn here, which is our shape C, it's starting at 10. I should use it. Starting at 10 and it's ending at 12. So this is 10, and then this is what? 12. So it means 12 minus 10, this is just 2. Okay, and then what about this distance of A from here up to there? So when I go to this time graph, this is 0, and then this is what? when you look at it from there, that is just 4. Okay, so here we are going to say this A is 4. Okay, and then what about this B? This B is the whole height from 0 all the way up to 8. So we are going to say this is 8. So we have the three numbers that we need in order to find the area of this, which will be our displacement for the part labeled C. Displacement for the part labeled C, okay, will just be half h and then a plus b. If you want, you can put the h at the end here. It's the same. So it will be half. Okay, what is the height? The height is 2. And then in the brackets, we are going to have 4 plus 8. Okay, so meaning here we are going to have 1 multiplied by 12. Okay, 1 multiplied by 12. So it means 12 meters here is our displacement, okay, for this part here labeled what? C. Okay, so I'm going to write C as a displacement of 12 meters. Okay, so we are remaining with D. So let's go on D there. So on D, we have this shape. It's a square. Okay, so here we are from 12 to 16. So that is 16 minus 12. It's just 4. And then going up, we are from 0 to 4. So that is just 4. So it means the displacement for D will just be what? Displacement is equals to 4 multiplied by 4. So this here is going to give us 16 meters. Okay, so meaning the displacement for D is just what? 16 meters. So we found the displacement for all these shapes, that we had. So meaning we can find total displacement. Okay, after 60 seconds. So we are going to say the total displacement is just equals to, we add the displacement for A, which is 8, plus the displacement for B, which is 64, the displacement for C, which is 12, plus the displacement at 16. So when we add all these here, what are we going to do? Okay, so you just show. Okay, so it means the first part here where they're saying how far does the runner go, second goes. Any questions there before we proceed to the next one? Okay, silence means there's no question. So I'll erase this and then we can look at the other part now. Okay, so the other part is saying what
thing that you should know about access. The speed can change, okay, is if the time has moved. Okay, the only way the speed can change is if the time has moved. So if the time is moving, I should say the other round. The only time that we'll know that there is acceleration there, it means that the velocity has changed. Okay, so velocity, it will be final velocity minus initial divided by the time. Okay, so here they're asking us for the acceleration at the time 2 seconds. So when I come at the time 2 seconds, this is the time. I go here. What is the acceleration at 2 seconds? What is the acceleration? The acceleration here is just this h, right? Okay, so it means the final and the initial velocity at this time 2 seconds is just the same. It's still 8. Okay, so to find the acceleration, we're going to say 8 minus 8 divided by 2. So it means the time there will just be what? 0. The acceleration will just be 0 meters